Hey there, geometry. Sorry, my AirPods weren't plugged into my computer. They were still plugged into my phone, so I'm not sure if you heard me say hello. We are in Unit 3, Lesson 9, and we're still talking about similarity, but now actual conditions where we can gauge whether triangles are similar or not. All right, first of all, how could you justify each statement? So here we have triangle PQR is congruent to triangle STU. Let me get my bearings straight here. All right, so triangle P prime, Q prime, R prime, which is this one, is congruent to triangle STU, which is that one. So here, when I see that angle R prime is congruent to angle U, R prime, Q prime is congruent to UT, and those are segments. And angle Q prime is congruent to angle T. I can say that triangle P prime, Q prime, R prime is congruent to triangle STU because of angle side angle. So these are all given if we're doing a proof. Okay, so cool. Now, angle PQR is similar to triangle STU. I'm going to erase what I've drawn up there so you can push pause and write it down real quick. But I need some more space. Ooh, I want the big eraser. I don't know if you hear my washer in the background doing some laundry. Okay, now we're going to do similar. So I see that angle R is congruent to angle U. Angle Q is congruent to angle T, and we can say that QR, hold on, let me remember how to write this. Okay, I got it. Let me erase that really quick though. I want to set up a ratio. So I'm going to say that QR over UT, RU, QT. So I'm going to say TU to keep it in the right order. Since we've said R is congruent to U and Q is congruent to T, I'm going to say RQ over UT, which I did not do correctly. I just want to keep it in the same order. It doesn't have to be. It just keeps my brain a little bit clear. RQ over UT is proportional to, so we just did this side and that side is proportional to RP over US. Okay? Does not have to be part of the proof, but I'm just going to show you that RQ is a measurement of 2, UT is a measurement of 1, and RP is a measurement of 3, US is a measurement of 1.5. If we simplify both of those fractions, we get 2 equals 2. Okay? So I can say that triangle PQR is similar to triangle STU. Did you see that similar symbol? Okay, that's important because of angle side angle similarity. And that means that the angles are congruent and the side is proportional. Okay? So this warm-up is a little hard because we're not actually warming up, we're actually learning something. All right? Okay, let's look at the next thing. So I'm not going to write out the proof quite as detailed. It's not a very difficult one, but okay, these are congruent. we have G prime, H prime, I prime, GHI, and MNO. MNO. So we know that G is congruent to M, G prime, and then G prime, H prime, side is congruent to MN, and then angle H prime is congruent to N prime. So those are congruent because of angle side angle congruence. Now, GHI is similar to MNO. Let's just erase this and go back to my pen. So G is congruent to M, cool. H is congruent to N, but we don't know anything about the side, do we? Nothing at all. So those would be similar because of angle, angle. All right, and what we're going to talk about here is what exactly do you need to prove similarity? Okay, with the first example, we used angle side angle, proportionality, and then for the second example, we only used angle angle. We didn't use sides being proportional at all. Okay, let's move on. So how many pieces? For each problem, draw 2 triangles that have the listed properties. Try to make them as different as possible. All right, so we're going to go over to Geogebra and draw each one. So first we're going to draw 2 triangles where one angle is 45 degrees. Okay, I can do any side, and then I can make an angle. Excuse me, what stinks about this part of the program is when I do an angle with a given size, it ends up being, they make the segment length the exact same as the original. So segment AB prime is the same distance as AB. I'm going to try something though. I'm going to do another segment. Well, there's my triangle with one 45-degree angle. Let's do another one that is visibly different. Let's see if I put a point on it that's shorter. Let's see what happens there. Oh, good, it worked. So now I can do a different. All right, so I just made 2 triangles with one 45-degree angle. I don't know if I can move it. I want to move the whole thing. Nope, it won't let me. It's fine. Are those triangles congruent? Are those triangles similar? No. If I did some measurements here, those are both 2.5 and 1.9, 2, 4.6, and 3.5. We couldn't set up any proportional measurements that were where the proportions were equal. In fact, I can do angle measurements right here, and I'm not going to see that the angles are congruent. Remember, for triangles to be similar, the angles have to be congruent, all 3 of them. You only have to prove 2 because the third one's going to be congruent, but the angles have to be congruent, and these are not. Let's see if I can measure them really quick. 67.5, 67.5. That's interesting. It makes sense though because that's an isosceles triangle. Okay, not congruent. All right, let's see what step 2 is. One angle is 45 degrees and the other angle is 30 degrees. Okay, 2 triangles like that. Let's see if we can do it. Let's start over. Get a lot of practice drawing triangles. angle with given size. Sorry, I pushed the wrong thing. Cool. Now I have to do an angle of 30 degrees. It's okay. Let's see if I can do it. Let's do another segment. And it was 30 degrees, right? Okay. So what I'm going to do here, so those are the two that I need to use. Oh, bummer. That's not going to work. Okay, let's delete those. You see where my 30-degree angle is? All right, so I'm going to put a point on here and do that angle. Oh. Okay. I need to clear some of this garbage. So I want to go clockwise. Let's try one more time. Select a leg, point, vertex, and end size. I want to go clockwise. There we go. All right. So we are going to do it's not big enough, but it's okay. Let me just do a line through here, show some intersections, and then I'm going to draw a polygon over it. I was hoping I could move the polygon away from all the stuff. Okay, there is one triangle with 45 and 30 degree angles. Now I'm going to make one that is significantly different. First I want to see if I can delete that line and not lose everything. Nope. Okay, so segment. I just needed that out of the way. First make it a little bit bigger. And 45 degrees. We want to go counterclockwise. And then I'm going to put a point on it, about right there, and do another angle. So select the point and the vertex, and I want to go clockwise, 30 degrees. Okay, and I'm going to draw a line through because I know G is not on that segment. I said line. And then I'm going to intersect those two. Cool. And draw a triangle over it. Make sure I get the right point. They're too close. Cool. All right, do those triangles look similar? Now I know we never, ever, ever say that things are anything because they look like it. If we measure that third angle, maybe. I can't do it. It's too small. Ah. All right, let's do this really quick. we have 45 plus 30 is 75. 180 minus 75 is 105. So that angle is 105, as is this one. Okay? And that's going to disappear. I hate that. So we have two angles that are 75 degrees apiece. So really I have angle, 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 and we know the triangles are similar. I don't know if I'm going to be able to do, oops, I have to turn off my pen. Distances, it's going to get really messy anyway. Nope. Distances. Okay, 1.6, 2.2, and I can't read that one. Exactly 3, aren't we lucky? Let's just see if the other one is the same. I don't want G prime, though I want H. I don't know if I'm able to grab H. I think I got it. Nope. Actually, I wonder. E, yep, it's H. Let's try one more time. Distance or length. Last time I got it. That's not helpful. There we go. This time I'm not going to be able to see the other one. Okay, let's try one more time, and then we're just going to have to trust. H, nope. H, E. That wasn't a real try. E, H. That's so annoying. Alright, let's just do the other two. Measure E, F, and F. Come on, H. Oof. Okay. It's my fault for making that G so close. I don't know. Maybe it was G I should have been trying to grab, not H. Because we see, no, I'm going to go with it should have been H. So if this is 3, that's 6.1. It's getting bigger, so 6.1 over 3 should be the same as 3.2 over 1.6 and 4.4 over 2.2. So it looks to be approximately a factor of 2, which means they are similar, not congruent, but we only did 2 angles that were the same and tried to make the rest of the triangles as different as possible. So what we want to prove here is one angle is 45, the other is 30. We still got similar triangles. One angle is 45, the other is 30, and the lengths of a pair of corresponding sides are 2 and 6. Okay, let's try that one, and then we'll move on. Oh, I can actually do a segment of a certain length. I know because I did it earlier. There we go. Now let's do an angle. Nope. All right, let's get this angle. angle with a given size. Leg. Well, not sure what's going to happen here. Oh, it worked. Make a segment. And then one more. Make a segment. So we made this one 2, and that one 2, or 6. Now let's do one more angle. We're going to do this angle as 30. And we want to go clockwise. I didn't think that would work. For some reason it was being wonky. Angle with given size. We did this before. Select leg, point, vertex, then enter size. Leg, cancel. That's not going to work. Let's see what happens. Well, that means that one's 30. All right, let's try that again. That went the wrong way. That'll work. No, it won't. Blasted. All right, I'm going to pause for a second. I did this earlier. Trust me. The second after I push pause, it all works out. All right, so we're doing this. And now it's not going to work. You watch. Let me get off of that. Start over. Clockwise. Okay, got it. Here to there. Clockwise. Okay, got it. Okay. So going from there to there. I'm going to show an intersection. And take some measurements. You're not going to be able to see those. I'll move them in a second. I have to move that measurement so I can see. Come on. All right, so 2 to 6 was a scale factor of 3, which means that 1 times 3 is 3. 1.5 times 3 is 4.5. So we have similar triangles. All we did was make 2 triangles with a pair of congruent angles, and we made similar triangles. All we need is angle, angle to prove similarity. All right, that was tough, sorry. So here, in our activity synthesis, just want to show that we're just showing our angle, angle, triangle similarity theorem. I can say that angle A is congruent to angle C, and angle DEA is congruent to angle DEA BEC. See how I named those in the right order? So those are given because they're marked on the diagram. So I can say that triangle DEA is similar to triangle BEC because of angle, 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 triangle, blah, 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 similarity theorem. Mouthful. All right, any two angles. So here are two triangles. One triangle has a 60-degree angle and a 40-degree angle. The other triangle has a 40-degree angle and an 80-degree angle. Explain how you know the triangles are similar. Well, I'm going to just check real quick. 40 plus 60 is 100. 180 minus 100 is 80. Okay, 80 plus 40 is 120. 180 minus, oh goodness, I'm so sorry. 180 minus 120 is 60. I get ahead of myself sometimes. So I have two angles that are congruent. Okay. Angle, angle, similarity theorem. Prior to that, I should say that the interior angles of a triangle sum to 180. How long are the sides labeled X and Y? Well, once we know that the triangles are similar, we can figure out the scale factor. So if I'm going from this triangle to that triangle, it's bigger. So my scale factor is going to be 5/3 because that's a number bigger than 1. And when our scale factor is bigger than 1, we're getting bigger. So 5/3 is, we can take each side. So I'm going bigger. So 6 times 5/3. 6 times 5/3. If I simplify that, it's 2. That would be 10. But here I need to go smaller. So I'm going to do 8 times 3/5. I multiply across the top and across the bottom. It's really 8/1. I get 24/5. So that one's going to be 24/5. I don't like that very much. 4.8. I want to make sure it's actually smaller. So that's it. So that's how we find our missing sides. We find the ratio. We think about it. Is it getting bigger or smaller? And then we do some multiplication. And that's it.